We're good.
Alright, so what we have here is the web interface for our adapter. This is for PCB1 right now, and it's constantly taking in readings, and we can look at different scales of the chart. The website is being weird. Let's just refresh that. Okay, so we can look at different scales of the chart. Specifically, I'm going to zoom in over here because we were taking readings last night, which is why you saw the long dip down, because it was off over the night, so it just wasn't receiving any readings, so it just draws a line between the two readings. But as you can see last night, up here we have it reporting between 116 and 113 watts, and that's powering this floor lamp right here, which is currently has a 60-watt bulb and actually two 60-watt bulbs in it for each section of the lamp, so a combined power of 120 watts. We measured this with a kilowatt, which is a device that measures power that you can buy commercially off the shelf, and we found that the lamp is drawing an actual 118 watts. So that means that our minimum, the time we were most accurate, we were only off by 2, and the time we were least accurate, we were still only off by 5 watts, which is well within the tolerance of 10%. And then you can see we turn it off over here, so it goes back down, and then we turn it over here with the small little blue lamp right there, which has a single 60-watt bulb in it, and as you can see, it's running at pretty much exactly 60 watts, so that is dead accurate. So it is reporting a correct amount of current, or the correct amount of power. So over here we have all of my different adapters. These ones down here are all just generic adapters that we've added, just so we wanted to be able to show that we could have more than one. We don't actually have the hardware right now to make 9 adapters. We couldn't quite afford that. But we have them all, and they even have their own little pieces of data once you zoom out on the graph. They have their own data set that we just put in manually, and you can see it's a continuous data set over a day, so it actually has all the data you would want to see. And you can even do fun things like you can compare the two of them, and then it just overlays the two graphs. So if you wanted to compare 2 different hubs, you could see that, oh, this one's using this many watts, this one's using this many watts. In this case, they have the exact same data, so they just overlay on each other. But I can go back to PCB1 and compare it, not against that one. Data again, and then we compare it against PCB2. You can see that PCB2 started out at using the 60-watt bulb, and then we switched it over to having the 120-watt bulb up here. So you can see down here it's using half, over here it's using twice. So it's pretty accurate, and you can really see where you're drawing more power. If we go over here, right now the PCBs that I have on my adapter list are currently highlighted red. That means that they're off. And when you click them, they turn on. So the little blue lamp over there turned on, and the PCB turns green. And I can turn everyone on independently, so I can keep turning on different lights, and the lights turn on, they turn green, and this is actually updated inside of the hub. Actually is keeping track of what the current state is, so it knows what it's doing. It's not going to forget which state they're in, and if I hit it again, it'll turn off, and then the text will turn red. So you know what's happening, and everyone is happy and dandy. Oh, and if you decide you have too many hubs that you're looking at, you can click the hub itself, and you can collapse them so you only see the hubs the adapters that you want to see. So
it also shows simple on-off rather than voltage graph?
It does not have an on-off graph. No.
Less technically inclined. All right, so that's your laptop view.
So to demonstrate the utility of the system, I'm just illustrating that I'm looking at the same web page on my phone. If we zoom in, as you can see, maybe you can't see, I also have PCB1, or first adapter being green over here, and the other 2 are red. And you can imagine a scenario where you leave your house, you're on your way to work, and you realize, I left the light on. So I'm just going to tap that. There. Turn it off. As you can see, my light turns off. Or you can turn the lights on if you know you're on your way home. So,
is there anything on the breadboard?
There is actually, if you want to flip over to the breadboard.
And then do we see 3 simultaneous plots in there?
PCB 1 is off, but PCB.
Oh,
I'm sorry.
Whatever you say, boss.
You do actually have to refresh the page to get it to show that. This is our first attempt at web interfacing, so we don't actually know how to do asynchronous refreshing. But they all show up as on now. That wasn't me pressing them; I was just refreshing the page. So, I mean, like if you changed it in one place, then you go to another place, be like, oh, I forgot, and you open the page, and then they would be there, ready to go.
All right. And how much power does your adapter use?
It peaks at half watt.
Okay.
It hangs around a third of a watt.
Have you tried to drop it on the concrete?
Not onto concrete.
We had some limitations in the actual parts we get, so we don't have an extra adapter to drop.
True. But at one point during our testing, we did accidentally knock it off the table, and it survived through that. So.
And we also arced AC power onto the board, and it survived.
Yeah.
Very rugged design.
Anything else? Any other functionality we haven't seen? Or?
Power outage.
Yes, we can, excuse me. The device is smart enough to toggle itself back on after a power outage. So if these have been on long enough for one reading interval, which is 1 minute, which I believe it has been now, we can simulate a power outage by turning, I'm going to, technically what you would do is yank the plug on the Raspberry Pi and then plug it back in. I'm just going to stop and start the control program because that's essentially what's going to happen when it boots back up and also save us about 20 seconds. So I'm going to kill the program. And then I would like to ask someone to turn off the transformer, which is, it's been protecting us from deadly wall power. And also, please turn it back on.
That light just died?
I think that light did just die.
It is on.
All right.
Oh, we didn't.
That light might have died.
So now,
No, I didn't cut out the actual board.
oh, you didn't?
No, because it's hard to do, because I have to actually unplug it.
Just don't worry about that
Yeah,
one for now.
that'll be fine. Yeah.
We can simulate this one.
Yeah.
So when I bring back the image that's running on the Raspberry Pi, it will read in a file from the SD card and remember the state that your devices were last in.
Yep.
Can you turn them off and repeat with me?
Yes, I can.
We have to wait long enough for the file to write out, right?
Yes, we do.
Yeah.
It writes out once per minute, which we
Yeah.
feel
Which
is
is the rate at which it gets the readings.
So-
enough.
What do you anticipate the production cost of your adapter and of the hub?
The hub is a Raspberry Pi, so we can most likely get it for 35 bucks and some change for instance, cables, SD card. Probably not looking more than $50 all told. An adapter, I believe, once we hit production, we can get them fairly cheap, maybe $20, $30 per adapter. The issue we had was that we were doing a limited run of a PCB, and that ended up costing us a lot of money. So we were looking, for our purposes, I believe it was $71 for 3 PCBs, on top of all the parts we used on them. So we're looking at...
Each adapter, for the purposes of this project, costs between $70 and $100. But that was...
However, when we hit scale, that can definitely change.
Yeah.
Yeah.
All right. So have we waited long enough?
Has it been a minute?
I don't think so.
Right, well, on this laptop, you can actually see the readings as they're coming in. I've only got this for debugging purposes.
Okay.
But this is what's actually being received by the server. So I can just wait for another set of readings to come in, and as soon as that comes in, I can kill the program here. See, right there, some just came in. So if I...
You need to unplug it.
Well, issue is they're both going to come back to off. Is that all right?
Yeah. That's what we want.
Yeah.
Oh, okay.
We want to see it.
This shows that they were different from last time.
Right, so turn it off and turn it back on, and I will restart the program.
Ta-da.
There's no lights.
Okay. Yep. It might have been more impressive if one had been off and one had been on if I switched it, but anyway, that shows us. I think we spent enough time. All right. Anything else from us?
Do you want me to talk about how it works? Or is that
Sure.
too low level?
If we could do it quickly.
I can do it quickly. Okay.
Because you're warehousing some data and doing lots of different
Yes.
things.
So fundamentally, at the heart of this is the Raspberry Pi. The Raspberry Pi is our hub unit. It has an XB modem and a slice of Pi attached to it, and the slice of Pi allows us to interface with the XB modem using the onboard serial port. So I have some Java code running on the Raspberry Pi itself that's acting as a control program. So this has 3 threads. The first thread is listening for commands from the server that say to turn on and off. There is a thread listening to the XBs for readings, and there is the main thread, which is the one that is sleeping and transmitting the readings and writing out the serialized file. We also have a virtual machine that is running a Linux-based server using Tomcat, eJabberD, and MySQL, and the 3 of those are performing basically data warehousing functions. So they're housing the API for the system, they're housing all the data for the system, and they're housing basically everything that someone else would need to make an interface to our product. That's about it.
All right, thanks guys.